In this video we're going to look at multiplying and dividing some fractions where we have more than one term on the top or the bottom. The actual process is exactly the same as it always is for multiplying fractions though. We start off by multiplying the numerators together, so that's x plus 1 times by 3x plus 3, and the way we represent that algebraically is to write out x plus 1 and then 3x plus 3 all in brackets. And then 3 times 2 we can evaluate straight away. We know that that is 6. At this point we have a choice. We can leave the numerator in its factorized form like that in the brackets, or we could choose to expand these brackets. Neither one is necessarily more correct than the other. What we will find with certain fractions over time is that it's a good idea to expand, or it's a good idea to factorize, because that might change the form of the fraction in such a way that we can actually simplify it even further. It takes a little bit of practice and a little bit of experience to start to spot when that's likely to be. To begin with though, it would usually be made clear from some sort of question you're given what you should do towards the end. Just so you've seen that we can do this either way, I'm going to expand the brackets now. So that would be 3x squared. That's going to be plus 3x plus another 3x. It's going to be plus 6x plus 3 all over 6. As it happens, in this case, if we look at the numbers in each term, 3, 3, 6 and 6, there is a number that will divide into all of them. They all have 3 as a factor in common. So we can actually simplify this further. That would become 1, 1, divide 6 by 3 and we get 2, and 2. So we are left with x squared plus 2x plus 1 all over 2. So as it turned out in this case, by expanding the brackets, we were able to simplify the fraction even further. This time we're going to divide two fractions, and we have a binomial in both of the numerators. To begin with, we can keep the first fraction, flip the second one, so we're going to invert that second fraction, or take its reciprocal, and then change the divide sign to multiply. Now if we multiply the numerators together, we have 3 multiplied by x plus 4, and again we need to use the brackets to show that we're multiplying 3 by all of x plus 4. And same again for the denominator, 9 multiplied by 2x plus 8. This time, even before expanding any brackets, I can see straight away that 3 over 9 could be simplified. So if I divide 3 by 3, I would get just 1, leaving me with 1x plus 4 on the top, and I would have 3 on the bottom. Now, as I said before, I could leave it in this form. I am going to expand that bracket on the bottom to give me x plus 4 over 6x plus 24. But there was clearly nothing more I can do with this. I have 4 terms, 2 on top, 2 on the bottom. I only have an x in 2 of the terms, so I can't cancel out any of the letters. 6, 24 and 4 all have 2 as a common factor, but there's no number in this term here. There's just a secret 1, so that doesn't have 2 as a factor. We can't simplify the numbers. That is as good as it gets. This is as simple as it gets. Here we have two more sets of algebraic fractions, multiplying them together here and dividing them together here. In a moment, pause the video and use either your mini whiteboards or a sheet of paper to try to simplify each of these expressions in turn. When you're ready, press play and the simplifications will appear one at a time for you to check your results.